Hi,
So,
Max. Sorry, Max.
okay, so we're going to take a look at congruent triangles. Before we get to that part, I want to talk about the parts of a triangle. Okay, so whenever I talk about the sides of a triangle, I'm talking about the segments. So there are three segments that make up this triangle ABC. What are the three segments? They're AB, perfect, BC, AC. Now, we don't care the order in which you put the letters, okay? AC is the same thing as segment CA, all right? All right, vertices. Okay, these are points. Vertices are points, so they're points A, B, and C. The only reason I'm breaking it down this simple is because on the homework or on a quiz, you'll say, oh, name the sides. You need to put the segment line above, okay, or name the vertices. The vertices are not angles. Next, we have the angles. Okay, so I just want to be clear on that. So the angles. Now, you can, since there's only one angle at point A, I can name this angle A, angle B, and angle C. But I could also have used three letters to describe angle A. I could have said angle BAC. But again, we don't need to overcomplicate it if it's unnecessary. Okay? Now, classifying triangles. Yes,
Is this when we're supposed to be learning that all angles in a triangle add up to 180? Because I've been using that in multiple proofs that I've done previous.
Right, so that's something that you usually learn in elementary or middle school, that the three angles, but this is where you actually get the theorem. Okay, so let's talk about identifying different angles or different triangles first. So we classify the triangles two ways, by angles, and then we're going to see by sides. So classifying triangles by angles, and then by their sides. Because usually when we classify a triangle, I want two words to describe it. So all triangles must have two acute angles. Does that make sense? Okay. Wouldn't make sense to have two obtuse angles. Could you make a triangle with two obtuse angles? No, it would not be possible. So it makes sense that you have to have two acute. It's based on that one angle. Will determine the type of triangle. So if the third angle is acute, in other words, all three are acute, you have an acute triangle. So we'll just draw a little picture. Yeah, you could say approximately. Maybe this is 59. Maybe this is 61. And this is 60. But they're all less than 90 degrees, okay? This is just an example. Okay, obtuse triangle. So that means two of them are acute, but that third one has to be obtuse. So maybe I have this as 120 degrees. A right triangle, again, the two are acute. The third one has to be a right angle with the little box. Okay. And now this is one specifically we've talked about, equiangular before. This is when all three angles are congruent. So we would just label that with the three arcs there. Notice this one is also acute. So it depends on how specific you want to be, but this equiangular triangle is also considered under the category of acute. Does that make sense?
For equiangular, all the angles are
yeah. Of course, we're going to look at theorems that say if it's one, it's the other. We'll get there.
For the acute triangle, you wouldn't be equal.
Right. That's why when Zachary asked, would they all be equal? That's why it's purposely labeled them different, just not.
So it's better to classify them as acute if you don't know.
Yeah, if you don't know the actual angles, even if it looks equiangular, just go with acute. Does that make sense? Only go with equiangular if you know for sure they're all the same. All right, now the sides. So we have scalene, isosceles, and equilateral. Okay, so scalene is when we have no congruent sides. It means all the sides are of different length.
The isosceles one looks like An ice cream cone.
So maybe this one, so the way we would label that in a picture, so when we mark the sides congruent, right, we would mark them with the same number of tick marks. So since all three are different, this one is not congruent to this one, not congruent to this one. That's how you would label or draw a scalene triangle.
This isn't talking about the angle.
This is no longer talking about the angles. Now, a scalene triangle, I could draw you an acute scalene triangle. I could draw a right scalene triangle, and I could make an obtuse scalene triangle. So you see, you can kind of mix and match. The only one I can't draw, I can't make an equiangular scalene. That wouldn't make sense. All right, isosceles is, here's the key in this wording, at least two. Okay, which means it could be 2 or 3. Generally speaking, when we draw an isosceles, we have one pair of sides congruent.
So isosceles triangles are equilateral triangles?
The
other way.
Okay, so this is a
All
great,
isosceles-
so this is a great always, sometimes, or never question. Okay, here we go. Isosceles triangles are equilateral triangles.
No.
Sometimes.
Because it's at least.
Now, what if I phrased it the other way? Equilateral triangles are isosceles. Always. That's always. Yeah, because here, take an equilateral triangle where all the sides are congruent.
At least 2
Does
sides.
this fall into this category all the time? Yeah. So every equilateral triangle also falls into that subcategory of isosceles. So I'll just put in here also isosceles. Okay. Now, if I give you a triangle and I say to classify it and I see all 3 sides are marked congruent, I wouldn't want you to just call it isosceles. I'd want you to call it equilateral. If you called it equilateral and isosceles, that's fine. But I'm really looking for, when I ask you to classify, I'm looking for the most detailed, like the most specific to that picture, okay? Now, here are 2 overlapping kind of triangles. We got a lot of different things going on here. It looks like this triangle. Here's a right triangle. And here, this is like equilateral. So can you find, what would you name as your equilateral triangle?
Triangle ABD.
Triangle ABD. And how about an isosceles triangle? CDA.
And is
No.
there a rule about like the triangle, the order we do it?
No.
Like is it
Okay.
like the vertex
The order,
one?
so the order is going to matter
Okay.
when we get to, we'll get to it. It has to do with corresponding parts.
Okay.
Like when we have more than one triangle and we want to compare the 2, the
Prove
order
that
matters.
Okay.
Okay, so
You
for,
have to prove sides congruent.
so, yes. Like if I have a triangle here and I say, oh, this is triangle ABC, and I want to make it congruent to this triangle, I have to say angle ABC congruent to triangle DEF. I can't, it has to do with A matches up with D, right? B matches up with E, that kind of thing. So we need to make sure it goes in the same order. All right, let's take a look at example 2. We want to find the value of X and then find the measure of each side. Okay, it's equilateral. Now, there's more than one way to do this.
Would it be x plus 9 plus 2x plus 3x minus 9 equals 36? No, equals 1,
You
no.
just do X
Okay,
plus
wait a
Y.
minute. Be careful. These are not referring to
You can
the
put
angles.
2x
They're referring
equals
to the
9.
sides.
So
It
X
would be
plus 9
2x equals
2X.
X
Okay.
plus 9.
There's basically, all 3 sides are congruent, but what do we really need to solve for X? We just need to set 2 of them equal to each other. Does it matter which 2 sides?
No.
So I take the 2 that are the easiest to set equal to each other.
2x and x plus 9.
Yeah. So I get X equals 9. Now, if you had tried setting these 2 equal to each other, you get the same answer. If you make these 2 equal to each other. Now, if they were inside, then we have to do something different. Okay, now find the measure of each side. That means, remember, when we draw or when we write down the 2 capital letters without anything above it, that means the length of the segment or the measure of it. So that means, what would RS be? 18. That means ST is 18. and RT is 18. So yeah, we don't really need to do any work for those. That's fine. Okay. Find the measure of x and the measure of the unknown sides of isosceles triangle EFG.
So just before x equals 2x.
So 16.
Anybody want to come up
So
here?
6.
You want to do it?
Can I put my finger on it, like my wrist on it?
Yes.
Okay.
So we get x equals 3 and the unknown side, so EF is 12 and FG is 12?
Oh yeah. Wow.
Oh. Thank you. So let's take a look we just have this last example, and then you guys can work on homework, or we can go over homework questions from previously. So the last one.
It's distance formula.
Okay. So we want to find the measures of ABC and classify the triangle by its sides. So in other words, we need to figure out if it's scalene, isosceles, or equilateral. Those are the three choices. Now, I don't have to actually graph this. If you wanted to, you could. But what I want to do is I want to find the distance. Let's review. What is that formula?
x2 minus x1 squared plus y2 minus y1 squared.
Good. So I want to find AB. Remember, that's the length of that segment AB. And then we'll find BC, and then we'll find AC, just basically pairing up each of those. So AB, we get 5 minus -4 squared plus 6 minus 1 squared. Right. So 81 plus 25 is 106.
Yeah.
Okay, we'll just leave it there for the moment. We could try to reduce that or change it to a decimal if you like. Actually, does anybody have their calculator? Just let's make it into a decimal so it's easy to compare.
10.3.
10.3. Okay, now we want to compare that to BC. So BC is going to be -3 minus 5 plus -7 minus 6 squared. Okay, so we have what? This will be -8 squared, so that'll be 64. -6 minus, or -7 minus 6 is -13. 169. So add that to 64. It's definitely not square root of 106. You're right.
So equal.
Square root of 233.
Equilateral is out.
And Maya, can you plug that into your calculator to get a decimal?
15.26.
Oh, 15.26. So we'll say 15.3. And the last one we'll do AC. It's okay. Sorry, Maya. All right, last one, AC. We have -3 minus -4, so plus 4. And then -7 minus 1 squared. So we get what? Square root of 65. And that's not going to reduce, but if you wanted to change it to a decimal, but clearly we can see this is scalene. So yeah, triangle ABC is scalene. So we found the measures. Anybody, what's up, 64, so what is that, about 8 point? Is it 8.1?
8.06.
There we go. All right.
Those are the